overly difficult. So what we're really doing today is a combination or a culmination of what we've been doing over the past few days. And really the first thing we have here, do not write all this down. Because what this is talking about here at the beginning is when dividing polynomials in the previous section, the example had non-zero remainders. Suppose the remainder is 0 when a polynomial f of x is divided by x minus k. So that when we do the division, this here, we get our whole numbers that we had, whatever it is, whatever that polynomial is, with a remainder of 0 over x minus k. Or anything over 0, 0 over anything is just going to be 0. So we're just left with the quotient q of x is the quotient polynomial. Therefore, x minus k times q of x will give me back the original function. And really what this is saying is that it is a factor. Whatever we divide, if we get a remainder of 0, then it is a factor. That means it will multiply by itself. It's one of our factors. A polynomial f of x has a factor of x minus k if and only if f of k equals 0. So if the remainder, when we divide or plug the number in, is 0, then it is a factor. That's what our factor theorem is. A polynomial function f of x has a factor x minus k if and only if f of k equals 0. So if it causes us, if we use synthetic division or plug it in, either one, and we get a remainder of 0 or get a value of 0 when we plug it in, then it is a factor. It's one of our solutions. And that's what we're going to look at first, is determining whether this x minus 2 is a factor. And there's two ways we can do it. The first is using synthetic division. The first way we're going to do this is using synthetic division. So we set it up. Now, the first thing we need to do is we need to solve this here, because we're taking this and dividing it by x minus 2. So I'm going to solve x minus 2 to get our value that's going to go in the cubbyhole. So we'll set it up as x minus 2 is equal to 0. And the first thing we would do here to solve for x is we would add 2 to both sides, telling you that x is equal to 2. And that's what's going to go in the cubbyhole. Now across the top, we're going to take the numerators of what's being divided. So our x squared plus 2x minus 4. Well, the number in front of x squared is 1. The number in front of x is 2. And then we have negative 4. And we're not missing any terms because we have our x squared term, our x term, and our constant. So we have everything that we need. And the next thing we do is what? We drop the 1. Any questions on any of this here so far? Any questions on anything we've done so far? Now we're going to start our synthetic division. So we'll do 2 times 1, which is 2. 2 plus 2 is 4. Then we will do 2 times 4, which is, and negative 4 plus 8 is, so what would the remainder for this be? Is this a factor? So what would the remainder be if it was a factor? The remainder would be 0. Is the remainder for this 0? No. So is this a factor? No. Because if the remainder is not 0, then it's not a factor. Then it is not a factor. Questions on this here? And that's it. That's all we have to do for this one. So this here this is not a factor. It's not a factor. So we'll move on to the next one. So this one here, we want to determine if b plus 5 is a factor of 3x to the fourth plus 15x cubed minus x squared plus 25. So I can use synthetic division to see if this works, because when we use synthetic division, if I get a remainder of 0, then it is a factor. If we get a remainder of 0, then it is a factor. Well, the first thing I need to do is, this here is going in the top. So I have 3x to the fourth, 15x cubed, negative 1 for our x squared. Do we have an x term? Well, no, so it would be 0, and then we would have 25. Then we would have 25. We still need to figure out what goes in the cubby hole. So we're going to do what? X plus 5 equals 0. We're going to solve this. And how would we go about solving x plus 5 equals 0? We would subtract 5 from both sides, giving us x is equal to negative 5. So negative 5 would go in the cubby hole. Any questions on any of this here so far? What would we do next? We would drop the 3. Negative 5 times 3. Bless you. Negative 5 times 3 is negative 15. So our first one is negative 5 times 3, which would give us negative 15, and we plug it in. Negative 15 plus 15 is 0. Negative 5 times 0 is 0. Negative 1 plus 0 is negative 1. So negative 5 times negative 1 gives me 5. 0 plus 5 is 5. And lastly, we have negative 5 times 5. Negative 25 plus, or 25 plus negative 25 is this a factor? Because the remainder is 0. Term is a factor. Yes, it's a factor. Any other questions on this here? Okay. Let's look at another one of these. Determine whether x minus 3 is a factor of f of x equals x squared plus 6x minus 12. Now, are there any questions on any of these that we've done so far? Bless you. So we can do synthetic division again. The numbers are going across the top, so x squared plus 6x minus 12. Well, we would have 1 for x squared, 6 for x, and negative 12. And I'll go on and we can drop the 1. Now, in the cubby hole, we're going to solve for x minus 3. Set it equal to 0 and solve to find out what goes in the cubby hole. So we would add 3 to both sides, telling me x is equal to 3. Any questions on how we set this up? So the first thing we would do is 3 times 1, which would give us 3, and we put it into the 6. 6 plus 3 is 3 times 9 would be our next step, because we're going to multiply. Would give us 27. And negative 12 plus 27 is 15. Is this a factor? No. No. Let's do this one again. So we solved this for x to begin with, yes? So we added 3. Because if this was a factor, we already know it's not. If it is a factor, it means x equals 3 is a solution. Is a solution for this function. So what I could have done is taken f of 3 and plugged it in. Now, when we did the synthetic division, we found that the remainder was 15. Yes? So let's see what happens here. Well, 3 squared is 9. 3 times 6 is 18 minus 12. 9 plus 18 is 27. And 27 minus 12 is? It gives you the same answer. We can't plug in negative 3. We have to still solve it for x. And then we can plug that value in. Questions on this here? Do we need to see another example of determining whether it is a factor or not? We feel good with this here? Yes? Okay. We'll skip these two. Okay. The last example or type that we're going to, this isn't the last one, but the last type we're going to look at. There's a slight change. Can anybody see what it is? Well, one thing it's telling us what? Show that. So is x plus 3 going to be a factor? It has to be. Because what are they telling us? They're telling us to show that it is. So they're telling us out front, x plus 3 is a factor because they're telling us to show that it is. They wouldn't tell us to show that it is a factor if it wasn't already. Then what? Then factor it completely. Then we have to factor it completely. So let's start off by showing that x plus 3 is a factor. So to do that, well, I'm going to use synthetic division. Here, plugging the value in, solving and plugging it in is not going to be helpful. So going across the top, I have x to the 4th, so we would have 1 for x to the 4th, 3 for x to the 3rd, 0 because we do not have an x squared. Then we would have our 1 in negative 3. Bless you. So we were missing the 0x squared. We had to add that one in. We had to add that one in. Now we need to find out what goes in the cubby hole. At this point, can anybody just looking at this say what's going to go in there? Negative 3. Because when we solve this, x plus 3 equals 0. I'm going to subtract 3 and get x is equal to negative 3. It's normally the opposite of that sign. But again, writing it out is not a bad thing. So you can write it out. We'll drop the 1. Then we're going to multiply our negative 3 times 1, which would be negative 3. Now, negative 3 plus, or 3 plus negative 3. Negative 3 times 0. 0 plus 0. Negative 3 times 0. Negative 1 plus 0. I feel like we can do multiplications of 0, yes? Okay. Now we're going to do negative 3 times negative 1, which is 3. And 3 plus negative 3 gives me, so it is a factor. We knew that from the get-go. We knew that this should be a factor. Now let's see what we have left. So let's plug the variables back in. Well, the negative 1, will it have an x with it? No, because it's the remainder, the term without x. The next one would be the term with, then x, and then x. So what do we have left here? I have x cubed minus 1, yes? Now this is being multiplied by something. It's multiplied by our x plus 3, because we said this was a factor, yes? When we have our factors, and we worked on factoring the last 2 days, and we did it in chapter 3, when we factored it out, we wrote it as sets of parentheses being multiplied together, yes? So since x plus 3 is a factor, I can rewrite this as x plus 3 times x cubed minus 1. And if we multiplied that out, we'd get back to x to the 4th plus 3x cubed minus x minus 3. Now we just need to make sure this is factored completely. So x plus 3, the degree is 1, yes? So it's factored completely. How about the other set of parentheses? The degree is what? 3. Well, it'd be nice if those are both cubes, wouldn't it? Is x cubed a perfect cube? Is there something times itself 3 times that gives us x cubed? Well, yes, it would be x, yes? Is there a number that multiplied by itself 3 times that gives us 1? Because what's 1 times 1? Times 1. It is the only number that we can take any root of. Because I can take the square root of 1, it's 1. The cubed root of 1 is, the 19th root of 1 is 1. Our tractor trailer. So let's do the signs. Well, before we do the signs, let's do the cube root so we get a and b. So the cube root of x to the 3rd is x. The cube root of 1 is, so we have our a and b. Now what would our signs be? They would be opposite, or so same, opposite, always end on a positive note. So for it to be the same, we would start off with a. Opposite would be positive. So our a terms were x. So here we would have x. Here would be x squared, and then this would be x. Our b is, here we'd have 1, here we would have 1, and here we would have 1 squared. Any questions? Yes? Well, for this one here, because x plus 3 is simplified, x minus 1 is simplified. Here, really, x squared is simplified. This here really simplifies down. We put them there, like when we saw yesterday where we had 2x for a. We need the parentheses around it just as a reminder to let us know that it's both the 2 and the x being squared. So for this here, we really didn't need the parentheses, but it's a good, if there's more than one term in either one of those a or b values, it's good to have them there. Now we're done, and I know that I'm done because this x squared plus x plus 1, will that ever factor? No. The quadratic that comes out of a sum or difference of perfect cubes will never factor. It will never factor. This is either going to give us imaginary or irrational terms, or both. So we're done with this here. Questions on this here? I'll cover that here in a little bit. This one? here. Because the 0x squared and the 0x cancel out because we don't have 0. So what's left after we divide is x cubed minus 1. Does that make sense? So that's kind of what's nice, is because looking at this originally, I couldn't find any factors, or it'd be hard to. But since I know one of them, since I know they told us this is a factor, I can simplify it down to something that we can't. That is essentially why we have synthetic division, because it takes something I really can't find the factors of. It'd be hard to see how this would factor. And we'll go over ways to actually be able to find factors, find solutions that would give us factors for these here to simplify from there. Is this on the note sheet? Should be on the back. Nope. Oh, it's out of order? Okay, it's out of order. Because I think it's on the back of the first sheet. So we're going to look at this here. So they told us one of the factors of this here. We're going to show that it works, and then we're going to factor it completely. So I'm going to start off with synthetic division. Going across the top would be 1, -2, 0, 1, -2. And well, eventually we're going to drop this one down. It will be 2 in our box in the cubby hole, because if we've solved it, 2 minus x equals 0. Any questions on this here so far? Okay, so now we can go on and do our multiplication. So 2 times 1 would give us 2. Well, -2 plus 2, 2 times 0 is 0 plus 0 is 2 times 0 is 1 plus 0 is. So we'd have 2 times 1, which gives us 2 again. So it is a factor. We knew that from the get-go, yes? Okay. So let's plug the variables back in. Well, remainder, the 1 would be the term without x, or a term without the variable. Then we would have x squared, and x cubed. But really, what would be left over from this here? Because we'd have the x cubed. Well, that's 0. That's 0. Plus 1. Because that's what we had left over from when we used our synthetic division, yes? Now, what was our other factor that we just found? X minus 2. So we have to rewrite that back in because these two are being multiplied together. Now we just need to make sure that none of these factor. X minus 2, does that factor? No, its degree is 1. How about x cubed plus 1? Yes, and it's a difference, or a sum of perfect cubes. Because the cubed root of x to the third is x. The cubed root of 1 is 1. So those work. So let's do our signs. The signs would be the same, opposite, always end on a positive note. So this would be our a, so it'd be x, nothing. Here this would be x squared. This would be x to the first, and then nothing. Our b terms would be 1, nothing, 1, and then 1, squared. Any questions on this here? Well, now we can simplify it a little bit. We'd have x minus 2 times x plus 1 times x squared minus x plus 1. Because x times 1 and 1 squared, well, negative x times 1 is going to be our negative x, and 1 squared is 1. Yes? Are we good with this here? Now, will it always work out that we'll have an x cubed plus 1? No. It's just worked out that these two here have worked out this way, and they set it up this way because, well, what did we go over just yesterday? Sum and difference of perfect cubes, yes? So they're using those because they're fresh on our mind. But any questions on this here? Let's do this one here. This will be the last one that we do. Now going across the top, 1 for x cubed, 5 for x squared, negative 6 for x, and then 0. And we're going to drop the 1. And then what's going to go in the cubby hole? It's going to be positive 6, because x minus 6 equals 0. We'll do our multiplication. We're going to do 6 times 1. Negative 5 plus 6 is? And we'll have 6 again, which would give us 0. 6 times 0 is? So let's see. So are there any questions on anything we've done here? We're good with this here? So let's look back through. So remainder. So this 0 will be the term without x. Then we'd have the term with x, and then the term with x squared, yes? So what do we have left? X squared plus x. Because that's it, because we don't need to include the 0. So we have x squared plus x. And what did we multiply this by? So x minus 6. Actually, before we move on, are there any questions over anything we've done here so far? So x minus 6 is completely factored. There's nothing we can do with it. It's degree 1, yes? Now, if we look at the other one, well, we do have a degree 2, so it might factor, yes? I don't have a constant term, so that kind of messes with the 2 sets of parentheses, 3 spaces and 3 spaces, yes? Because it's a quadratic. Degree is 2. So we wouldn't use the tractor trailer because I would need a degree 3 and a degree 3, something that would cube the first and second term. Well, what's one of the first steps we did before we did any factoring? We always found a what? Starts with a G. Is there a greatest common factor between these two terms? X, they share an X, yes? I can factor it out. So I can pull an X out of this here. And if I factor an X out of this here, well, X out of X squared leaves me with plus 1. Because an X out of X, they factor out completely, so I'm left with 1. Where do I put the other one, that X minus 6 set of parentheses? I can put it out front, but I could also put it right. Multiplication, the order doesn't matter. And whenever we have a greatest common factor, we always want it in front. You really don't want to write a greatest common factor between 2 sets of parentheses. It just doesn't work well. You always want it out front. So here, it just worked that there was a greatest common factor we had to factor out. And now we're done. That is factored completely. Any questions on this here? Now, This is looking ahead into next week. Supposed to be an R there. Y'all remember the zero product property? Zero product property stated if I have A times B equals 0. If I have two things multiplied to equal 0, well, what do we know about A and B? One of them has to be 0. Zero product property, when we covered it last chapter, just said A times B, yes? What about A times B times C? One of them still has to be 0, yes? Does it matter how many things I've multiplied together? Wait a minute. If I wanted to solve this, do I now have it set up in a zero product property form? That's why we're doing all of this. That's why we're doing these steps. That's why we're going over factoring and all of these different methods to solve. Because if it's factorable and I can get it down to this form, I can solve it. I can solve it. Synthetic division. Each one of those that works out to be 0, that gives us a remainder of 0, that number is a solution. So all of these here, this here, 6 is a value of x that will make this function equal 0. Did you remember that for quadratics? When we were solving for the quadratic, we're trying to find values of x that makes the function equal what? 0. So wait a minute. That means if this is a factor, makes it equal 0, it means that 6 is a solution, isn't it? So one of the values or solutions for this would be that x is equal to 6. Does that make sense? That's what we're going for. That's what we're aiming towards. That's why this is helpful in solving. Now, will this always help us solve? No. Because we have to plug in real numbers. We can plug in imaginary numbers. It still works, but it's more complicated. And there's different methods we do for that. But that's all we're going to cover for this here.